going, guys? Welcome back to the channel. So in today's video I'm going to be showing you how to test your air conditioning on your Mini. The air conditioning system comprises of the battery, which is under here. We've got the control switch, which is inside the cabin. We've also got a relay, which is in the footwell module. If you've got an older Mini, you'll also have a relay inside this box here. You've also got a air conditioning compressor, which lives underneath the alternator. And on the compressor, you've got a clutch coil. So anytime that you switch on your air conditioning there and it meets the criteria with the ambient temperature and the temperature inside the cabin, that'll then bring power on to the compressor clutch, which will then bring on your compressor. What I'm going to do first of all is check the voltage at the battery. So I'm just going to get a meter. I'm going to put that to voltage DC. I'm then going to go across the terminals of the battery. And as you can see there, I've got 12.6 volts DC, 12.5, 12.6. So the battery is fine. What I'm going to do is test everything electrically as best I can before we look at the refrigeration side of the system. Now that we've checked the battery, what I'm going to do now is check the fuse which lives inside this footwell module. So if you've got a right-hand drive vehicle, it's on the driver's side. If you're over in the United States and the other Arab countries, then it's going to be on your passenger side. Now what I've done is I've plugged in the OBD reader into the connection which lives under here. I've scanned all the modules in the car and the air conditioning doesn't come back with any faults. So as I said, I've checked the battery, I've made sure I've got good voltage there. What I'm going to do now is just check the fuse which lives inside here. So we'll just take that cover off. As you can see, there's a lot of fuses in here, a few relays. Now, if you look here on this panel, on this legend here for the fuses, you can see that the air conditioning on this model, this R56 model, is here. This is your little snowflake symbol, which signifies the air conditioning. It's a 5 amp fuse and it's fuse 29. So as you can see, this is your first row of fuses, your second row of fuses, your third row of fuses, and the air conditioning is actually the bottom fuse on the third row. Okay, so this is the fuse here, this 5 amp fuse here, this orange one, which as you look here, as I say, this is your first row of fuses, your second row of fuses, your third row of fuses, and then it's the very bottom one, fuse 29. What we'll do now is we'll just pull the fuse out and quickly check it, just to make sure it hasn't actually been damaged in any way. So as you can see there, there's the little connection inside between the both sides of the spades is still intact. It's not actually blown, but you can actually check it electrically as well, just to make sure that there's continuity there. So we'll do that now. What I'm going to do now is just check this fuse. So in order to do that, I'm just going to go into the ohm scale here on the meter. I'm then going to touch both ends together. I'm getting a noise there, but obviously if you don't have the bell attached to your ohm scale, you just need to look at the reading here. As you can see there, it says OL, which means open line, which is an open circuit. And then when you touch it together, it goes down to 0.0, which is a short circuit or a continuation. So what I'm going to do now is check the fuse, put either end of the meter onto the spades here of the fuse. And that proves that the fuse is indeed okay. I'll put the fuse back in the car inside the module and then we'll check the next step. I'll just put the fuse back in the correct spot. like so. Now another thing you can check is this blue plug here. This white wire here actually goes out to the compressor. So what I want to do is pull this plug and make sure there's no any corrosion at the back of this, because sometimes these cars can get water leaks in here, and you can get water coming in here which can obviously damage the electrics. Now there is a relay, K19 relay, which feeds the air conditioning unit, but unfortunately on this module it's actually soldered onto the board. You can't actually change it like the way you would be able to change this one here, this relay. So all I'm going to do is pull this out, check all of that, and then what I'll do is go to the compressor, turn everything on and make sure I've got power at the coil of the compressor on the clutch. So we pull that out like so, check the back here. As you can see, there's no corrosion at all, everything looks good. The white cable is tight, it's in its correct spot. And then what you would do as well, just have a look inside here, make sure all the pins are good. As you can see, if I can get this to focus, as you can see all the pins are in good condition in here at the back of the module. There's another fuse here with the snowflake symbol, which is fuse 34, which is a 7.5 amps. So we'll check that one now as well. In addition to that, there's also the heater blower. I think that's that one here, F48. So I'll check that one as well, just to make sure. As you can see, that's the first row, the second row, the third row, the fourth row, and then it's 1, 2, 3, 4, 5. So it's the fourth row and the fifth fuse down. So first row, second row, third row, fourth row, and it's the fifth fuse down. So there's none in there, but we'll still count that. So that's 1, 2, 3, 4, 5, and then that obviously corresponds to the legend here, which tells you it's a 7.5 amps. So I'll just pull that fuse out now as well. That fuse is okay. Right, I'll just put this fuse back in its spot. So that was the fourth row and the fifth one down. Right, what I'm going to do is check the fan motor for the condenser, make sure the fuse and the relay is okay in here. As you can see, the fan motor for the condenser is F8, which is a 40 amp. So we count along here, F8, 40 amp. We've also got relays here. So if you've got single speed, then you've got double speed. R3, R4, relay 3, relay 4. So what you can do, you can actually swap the relays round, and you can also check the resistance on the coil on these. So we'll do that now. Let's just pull out this fuse. As you can see, there's a continuous line inside, but we'll check it anyway. As you can see, you've got 30, number 30 there, and then 87 and 87. If you follow that there, it's just the power comes in on 30. This is a normally open switch on the relay. As I say, normally open, then it comes down through on number 87 and 87. 85 and 86 is the coil. So it's an electric magnetic coil on this relay. So as soon as 85 and 86 gets the 12 volts across it, that will energise the relay coil, and then this switch will close, and then that will bring the power in through 30, down through 87, down to the cooling fan. So what we want to do is just check across 85 and 86 to see if we've got a resistance there. Also check 30 and 87 to make sure it's open line, because this should be open. You can put a 12 volt DC supply across 85 and 86 to make sure that the switching part here, the normally open switching part, closes, and then you would have power coming out on 87. I'm not going to do that just yet. Same again, I'm just going to go into the ohm scale here to check the resistance. Excuse me. And then what I'll do is I'll go across 85 and 86. So that's 86 here. And then that's 85 there. So let's do that now. As you can see, I've got 92 ohms. So there is a resistance there. So that's not open circuit. And then what I'm going to do now is just check across 30 and 87, which is the top one here, which is 30. And then any one of these two 87s, this should still stay open line. As you can see, it does. So that proves that the relay is actually open just now, which is great. See, all you would do is put your 12 volts across the coil, 85 and 86, and then you would hear it clicking, and then you would check for power on 87. You would put the power in through 30 and then out through 87. So I'll just put this one back in its place. And then check this one here. That's the same again, that's around about 92 ohms. Open circuit, which is correct. Okay, so everything seems okay so far. What I've done is I've put the power, the 12 volt supply onto 85 and 86 on the relay here, and then I'm just connecting it up to the battery because I don't have a 12 volt DC supply or transformer. So all I'm going to do now is just put the feed here onto the positive of the battery, and then you'll be able to hear this clicking. If it's faulty, it won't click. Okay, and then I'll do the same on the other relay here. The next stage now is I'll get the car started. I'll get the air conditioning switched on, make sure everything lights up on the control panel, get the car up in the air, and then we'll check for voltage at the compressor clutch coil. Okay, I'll turn on the ignition. So what I'm going to do is take it off auto, turn everything up full fan, lowest temperature setting, as you can see, AC button on, recirculation button on, start the car, and then get the car in the air. The engine is turning, but as you can see, the compressor is not spinning around. So another thing you can do is you can check the power going into the fuse, coming out of the fuse when you back probe it. So if I go onto the 5 amp fuse 29, 1, 2, 3, which is this one here. 12 volts DC on the incoming side of the fuse. 12 volts coming out. So again, we check the other fuse. 12 volts coming in. 12 volts going out. I then go onto the white cable here, which goes out to the coil for the compressor clutch. Nothing on that at the moment, so what I'll do is I'll turn on the car, I'll switch the car on, and then I'll put the AC switch on, and then we should hear the relay clicking in here if it's working, and then we should be getting voltage coming out here. If we get voltage coming out here but nothing at the compressor, then there's a break in the cable. If we don't have anything coming out here on this white cable, it means that the actual relay output of the relay is faulty, or the low pressure switch is open circuit. Okay, we've got voltage there, as you can see, 15 volts going out to the compressor. So now I'll go out to the compressor and see if I've got voltage at the compressor coil. I'm now testing for voltage at the other end of the connector block. The conclusion is this connector on the actual compressor itself is faulty. Now if I put my test meter probes across the positive and the negative there, I get 12 volts. Well, I'm getting like around 15 volts, I should say, because obviously the alternator's charging the system. So I've got full voltage here. If I test the cables, if I back probe the cables here, I'm getting 0 volts. If I open the connection and then check the pins inside here and here, I then get the resistance of the coil. So that tells me that the actual connection here is fine going to there. So the issue is obviously when these two connector plugs join together, they must be worn away inside and you're not getting a good proper electrical connection. So I don't want to butcher this. I mean, I could cut this connector block off and then just solder the cables here, join them through, but I don't want to do that because it will just make it messy further down the line if I ever need to change anything again. So all I'm going to do is just get a new compressor with a new connector. So what I'll do is I'll check the continuity across this plug here. So I'll go from the white onto the red. As you can see, there's nothing there. Brown onto the green. Nothing there, it's an open line. I've changed my mind. I've decided just to hardwire this, take off the plug and hardwire this. I mean, this is an older car, so rather than buy a new compressor, I'm just going to hardwire it. Now, the cables are very short, so this is going to be a tad difficult. I've just put some heat shrink over this. As you can see, that's everything now connected up. So we'll give it a try. You can see now that the clutch on the compressor is engaged and the compressor is spinning, although it is short cycling. In other words, it's coming on and off very rapidly. do is I'm going to open the valves here on the system and then check the pressure here. On the outer ring we've got kPa, and then on the inside there we've got PSI. So what I'll do is I'll try and dig up some literature once I find out the pressure and see what the pressure switch actually switches off at, and see what that is in relation to the pressure that I get here. We're sitting around about 120 kPa, or what's that, about 17 psi. A good way to tell if the system is low, if it's running on 134A, is if you look at the temperature gauge here and then you compare that to the ambient temperature. So if the ambient in here at the moment is 25 degrees Celsius, you would expect this needle to be sitting around about 25 degrees Celsius. This system runs on -30, which obviously does run about 40% lower than 134A. So there is a good chance that this system just needs topped up, just a little bit more refrigerant put back in it. I mean, so if this is say 25 degrees Celsius ambient, the refrigerant, as I said, should be around about that when it's all settled. And if this is running on -30 high chill, it's about 40%. So at 25 degrees Celsius, we should have maybe roughly about 600 kPa. So 40% of 600 would be about what, 200 and something? So it definitely seems as if the system's low. Now I've checked the literature online. As I explained, the pressure I've got here is around about 120 kPa or 17 psi. I looked at the literature, and on the low side here, the minimum amount static pressure should be about 23 psi. So the system's definitely short. So what I'm going to do is just add a little bit of this refrigerant here, and then see if we can get the compressor to come on. So I say it is a little bit low, and this is one of the problems when you actually remove your R134A and you change it to this -30, because this system runs at a lower pressure. What I'll do now is I'll start up the car and then we'll see if the compressor kicks on. The temperature's starting to drop now, that's good. I've got around about 6.2 degrees Celsius, so that's perfect. That'll do me. I hope that this video has helped you in some way, and it just goes to show you that never overlook the obvious. Anybody testing this system would have seen the voltage at the compressor. Compressor wasn't coming on, so they would have probably thought that the coil or the clutch was faulty, or indeed the compressor, and they would have went out and replaced that, even though that wasn't what the fault was. So hopefully this video has helped you in some way and gave you a little bit more understanding in how to fault find on your AC system in the Mini R56 series. And once again, I'd just like to thank you for watching the video. Thanks very much. Take care.